Okay, this lesson is a discovery lesson, and so you should have already done it. So if you have not done it, then you need to stop and do it. And this is actually 6.6 for us. So 6.6a. So like I said, if you haven't done it, stop and do it. But if you already have done it, then let's just go through it real quick. I just want to make sure you made the correct conclusions. So when you did these up here, you should have realized that they are the same, meaning they mean the same thing. So what we can conclude is that when you combined logarithms, then you multiply the arguments. Multiply arguments when you're combining those that are being added. Okay, so if the log is being added, multiply the arguments. And for all of these, bases must be the same. Every single time, bases must be the same. Okay, so by the way, what is the base of all of these? Yep, 10. They're all base 10 because if there's not a number, you assume the base is 10. We learned that in our common logarithm lesson, which was 6.4. Okay, so the first, there's three properties that you should have discovered. And the first one is called the product property, and I will refer to them by name in class, so make sure you know their names. And the product property says that log base b of m plus log base b of n equals log base b of m times n. So you can just multiply those two numbers together, and that is one of the properties. So an example of this might be log base 4 of 15 plus log base 5 of x, 4 of x. So together that would be log base 4 of 15x, because I multiplied them together. So it's just a way of taking two logarithms and combining them into one logarithm. You multiply the two arguments if they're being added. Okay, so the next property is called the quotient property, and the same thing, you should have done all of these right here and figured out that they are the same. And in this case, if the logs are being subtracted, then you divide the arguments. Okay, and so the property here would be log base b of m minus log base b of n. Okay, so if they're being subtracted, then you divide. So an example of that would be log base 4 of 15 minus log base 4 of x would be log base 4 of 15 over x. Okay, so once again, I've taken two logs, made them one log. Because it was subtraction, I divided the two arguments. Okay, so that's product property, quotient property, and see they make sense because quotient means to divide, product means to multiply. And the last one is called the power property. Okay, so once again, you should have done these, and they should be the same. And so from the examples, you can conclude that if there's a number out in front, then you move that to be the power of the argument. So any coefficient, I think I spelled that wrong, should be the power of the argument. Okay, so log, so this is b, log, I'm sorry, not b. Let's start that one over. N log base b of m. So this exponent moved to become the coefficient, or the coefficient moves to become the exponent. Either way is the same idea. So an example of that would be log base 4 of 15 to the x. You could also write as x times log base 4 of 15. So this term here can go here or there or back and back and back and back, wherever you need it based on the problem that you're doing. However, I do want to make one little mention. If you have something like 2 log of 5x and you change it to log of 5x squared, remember the squared would go to both terms, not just one, so it would be log of 25x squared. Okay, so that's just a little quick overview of this lesson. Like I said, it was a discovery lesson. Try the practice problems. Some of them are a little tricky, the first two especially, so try some other ones maybe. The answer key is online. Give it a look before you try 6-6.